So good afternoon everyone. Welcome you all for the amines chapter class. As we discussed in the last class, today we will be discussing about the amines chapter. So hope all of you are ready for this chapter and have done a revision of this chapter so that this crash course will work effectively. Okay, so students, shall we start the class? Are you guys ready? Yeah, give me your response so that I can start the class. Amines, it is actually a small chapter, but actually good number of questions has come from the amines chapter, so we will be discussing everything in detail about this one. Yes, okay, so students, today first of all we will be going through the important topics. Of this one, preparation of amines. This preparation of amine is the first topic that we will be discussing. In that we will be discussing about how we can prepare amines from nitro compounds, nitrates, amides and all. Then ammonolysis of alkyl halide. Then Gabriel thalamate synthesis. Two important synthesis of amine, Gabriel thalamate and Hoffman bromide degradation. Then the basicity of amine. Especially in the case of difference of basicity of amine in the case of gaseous phase and aqueous phase. Okay. Then the chemical reaction and distinction test, that is acylation and alkylation. Okay, then carbalamine test, and then the reaction with the nitrous acid, then Hinsenberg test, then electrophilic aromatic substitution. All these are the another important chemical reactions and the distinction test for amines. Now the last one and very important one, that is diazonium salt and the reactions of diazonium. Okay, so these are the important reactions that we will be discussing in the today's class. Okay, first one is preparation of amines. Reduction of nitro, nitrates and amine. This is the first and important one. Reduction of nitro, nitrates and amine. How we can prepare amines from nitro compound? First of all, RNO2. First of all, we can do hydrogenation of nitro compound in presence of different metals, that is catalyst, that is Rani nickel, then platinum or palladium. These are the metals that we will be using for hydrogenation of nitro compound. What I will be getting, just remove this NO2 and add NH2. You will be getting the amine. Okay, now another one is in presence of HCl. What I will be getting, that is HCl in presence of active metals. Like tin or iron, active metals like tin or iron. What I will be getting, the same thing, I will be getting the amine. And also RNO2 plus another metal like Fe in presence of HCl, I will be getting RNH2. So these are different ways I can prepare primary amine by reduction of nitro compound. First is by the hydrogenation, next is by treating it with HCl in presence of active metals. Okay, and in this the reduction using iron and HCl is most preferred. What is the reason? Because FeCl2 that is formed, which will be hydrolyzed to release HCl, requires only small amount of initiator acid. So we will be preferring the metal iron. Okay, this is about the nitro compound. Now we can move into the nitrates. For nitrates, how we can prepare? Are you done? Have you taken the note of it? Three important one, how we can prepare amines. Okay, now we will be moving into the nitrates. From nitrates, how we can prepare? Shall I move, students? Have you noted everything? Okay. From nitrates or cyanide. How we can prepare it? That is RC triple bond N, cyanide. From cyanide, I can reduce it by using lithium aluminum hydride, or I can also reduce it by using sodium amalgam in presence of ethanol, C2H5OH. Okay, what I will be getting in both the cases, I will be getting amine. CH2 amine. Okay, and the second method of preparation, we will be calling it as Mendius reaction. Okay, and the resulting product, it will be producing primary amine with the same number of carbon atom. If we want to prepare amine with the same number of carbon, this is one of the method you can use. Okay, and now this is nitrile. Now instead of that, if I am using isonitrile, what type of amine we will be getting? Lithium aluminum hydride. Anybody will be knowing? If I am using isonitrile instead of nitrile, if I am using isonitrile or isocyanide, what type of amine we will be getting? Anybody have idea? Primary, secondary or tertiary? Let me know quickly in the chat box. Anybody? What of, by looking itself we can say, right? What of? Yes, very good, Kiran. Secondary amine we will be getting, that is RNH CH. We will be getting secondary amine. That is what you have to do is just break this triple bond and fill the valency of nitrogen and carbon with hydrogen. That's the only thing you should do here. Okay. So these are the important points that you have to note down in the preparation of amine from nitrates. Okay. Is it done, everyone? Just note it down. Just note each and every single point. Yes. Shall I move? All done? Everyone? Hope all of you are making the notes and everything and listening to the class properly. Shall I move, students? What about others? No response from others? Okay. Yes, thank you. Next is from amides. From amides, how we can prepare? The reagent we will be using is lithium aluminum hydride. Lithium aluminum hydride, already we discussed about it in the aldehydes, ketones and either chapter. It can reduce, it will be reducing amide to amine, that you already discussed. What is going to happen? RC double bond O NH2, this is amide, that is amide. So what is going to happen? Just remove this C double bond O, remove and just make and convert it to CH2, RCH2 NH2, RCH2 NH2 you will be getting. What is this? This is primary amine. Okay. And if I am taking a secondary amine, we will be getting secondary amine, like that it will be going. Okay, so this is how easily we can prepare amine from amide. Okay, so three important ways we can prepare primary amine, that is by reduction of nitro compound, nitriles or isonitriles, and then amides. So all these three ways we can prepare amines by the reduction. Remember the reagent which we have used, lithium aluminum hydride, hydrogenation in presence of uranium, nickel, platinum or palladium, then using HCl in presence of active metals like tin or iron. Okay, these are the three important way in which we can prepare primary amine. If it is done, shall we move, students? Are you done? Okay, yes. Okay, next one is ammonolysis of alkyl halide. How we can prepare alkyl halide using ammonolysis method. Here first of all we are taking the ammonia. Ammonia is the primary substrate we will be using, and ammonia will be treating with the alkyl halide. Ammonia which will be treating with alkyl halide. What I will be getting? This lone pair will be attacking on this R. There will be removal of this X bond, and you will be getting RNH2, which is primary amine. Yeah. And this primary amine again on reacting with the alkyl halide. What I will be getting? I will be getting R2N, that is secondary amine. And this secondary amine, if we again treated with alkyl halide, what I will be getting? Tertiary amine. And the last, what we will be getting? Quaternary ammonium salt. Quaternary ammonium salt we will be getting. Okay. Yes. Disadvantage. What are the disadvantages? It gives a mixture of primary, secondary and tertiary amine and quaternary salt, making it hard to separate. That is what of the disadvantage. This will be continuous. The reaction will be continuous till the preparation of or till the formation of quaternary ammonium salt. Why? We will be giving excess of alkyl halide. If we give excess of alkyl halide, reaction will be continuous till the formation of quaternary ammonium salt. As it is forming all these three, it is very difficult to separate it individually. But if you want to get primary amine as a major one, what you can do is, instead of keeping alkyl halide in excess, you can keep NH3 in excess. If you keep NH3 in excess and alkyl halide in less amount, we can prepare or we can get primary amine. Okay, and quaternary salt you will be getting major when you use alkyl halide in excess. If the alkyl halide is in excess, we will be getting the quaternary ammonium salt. Okay, so this is another important preparation of amine by the ammonolysis of alkyl halide. and this is also also a preparation reaction in not preparation, it's also coming as a reactions of alkyl halide in haloalkanes and haloarenes chapter. Okay, so students, shall we move? Have you got the idea how to prepare amines through this method? Yes. Moving to the next. Next one is Gabriel Thalamide synthesis. Gabriel Thalamide is another important synthesis. Okay, it's a name reaction, so keep in mind this is an important one. Gabriel Thalamide synthesis, the substrate that we are using it is phthalimide. Yeah, what is phthalimide? Yeah, C double bond O NH. Okay, NH, and this will be on treating with a KOH. On treating this one, what is going to happen? The lone pair will be attacking on the proton. What I will be getting? I will be getting the anion of phthalimide. I will be getting anion of phthalimide, and this anion of phthalimide will be reacting with the alkyl halide. And remember that the alkyl halide that we are using is primary alkyl halide. Okay, and why we are using primary alkyl halide is this step will be going through SN2 mechanism. SN2 mechanism means substitution, that I am going to substitute this alkyl with this anion. Okay, and on substitution, what I will be getting? I will be getting note down the product that I got here. NR I will be getting. Now the anion will be attached with the alkyl group. Now the last we will be treating it with the NaOH. Last we will be treating it with NaOH. And how we can write the final product? Just break this bond and put ONA here, and break this bond, put ONA here and H here, like that here also, ONA and H, and finally we will be getting RNH2, that is primary amine. We are getting primary amine because here we are using primary alkyl halide, and the phthalimide is converting to ONA plus, Na plus, will be converting into a salt. Okay, this is the complete method of preparation of primary amine by using Gabriel Thalamide synthesis. And as we can only use primary alkyl halide because it is SN2 mechanism, we can't prepare we can't use secondary amine or tertiary amine. And not only that one, we can't prepare aniline also, aromatic amine, that is aniline. Why we can't prepare aniline? Because for aniline we know that there is a partial double bond character. Because of the partial double bond character, the elimination of the nucleophile will be very difficult. Okay, that is elimination of nucleophile will be very difficult because this will be R or aromatic compound, and the halogen will be involved in the partial double bond character. So this elimination of halogen will be difficult. So because of that, we can't prepare aniline also. Primary aromatic amine also we can't prepare. Okay, that's the point we have noted down. Only we can prepare primary aliphatic amine. That's the point here. Have you got the complete reaction? Yes. Any doubt anybody is having? Students, shall I move to the next? Or do you want time to write it? Okay. Moving to the next. What about others? Do you want time to write the things, or shall I move? No response. What happened to everyone today? Are you guys not in a good mood to learn today? Okay, we'll be moving to the next. Okay, next one is Hofmann bromide degradation, another important reaction of the preparation of amine. Okay, Hofmann bromide degradation reaction. CO or C double bond O NH2 amide. We will be getting an amide, and this amide will be treating with NaOH or any base and Br2 and NaOH. What I will be getting? I will be getting an alkene. Sorry, I will be getting an amine with one carbon less. What is going to happen is remove this CO and just make as R NH2. Remove this CO and make R NH2, and we will be getting primary amine here. Okay, that is the only thing you have to do, Hofmann bromide degradation. And another important point you have to note down is nitrene. This mechanism of this reaction involves the formation of nitrene intermediate. Nitrene, which is specifically acyl nitrene. What is acyl nitrene? RC double bond O N 1 2 3 4. That is nitrogen with a 6 electron. That is an electron deficient species. What is going to happen is this nitrene will be involved in the involving in Curtius rearrangement. Will be involving in the Curtius rearrangement, and we will be getting isocyanate. So either acyl nitrene or isocyanate. Acyl nitrene or isocyanate. Any of these is the intermediate that is happening in the Hofmann bromide degradation. This also can ask in the question. Acyl nitrene which will be involving in the Curtius rearrangement, and we will be getting isocyanate. Okay, so these are the points you should note down in Hofmann bromide degradation. Done everyone? Have you noted down the intermediate and the product? How we can write the product? If you want to prepare an amine with 1 carbon less, you can use Hofmann bromide degradation. Okay, shall I move, students? Okay, anybody have any doubt? Okay, next one is the preparation reaction is over. Next is about the gaseous basicity in the gaseous phase and the aqueous phase. Basicity in gaseous phase, already you know, there is no confusion in that one. That is based on the plus I effect. That is tertiary amine. Tertiary amine, if you observe, there are 3 methyl groups are there. 3 methyl group. Plus I effect will increases the basicity, and minus I or minus effect will be increases the acidity. That is already we discussed in the GOC chapter. So more the plus A group is for tertiary, so tertiary will be having highest basicity, then secondary, then primary, then ammonia. Okay, now when it's coming to the aqueous phase, the point you have to note down is there will be 2 cases occurring. That is, if the alkyl group is R group is a methyl, if the R group is a methyl, the order of basicity is secondary greater than primary greater than tertiary. And if the R group is ethyl, if the R group is ethyl, then secondary greater than tertiary greater than primary, then ammonia. This is the order. Remember the number 213 and 231. This is very important one. The reason why there is a difference in the it's due to three effects. First one is inductive effect, then solvation effect, and then hydration effect. These 3 effects are the reason why there is a different order of basicity in the case of amine. Okay, then just note down these 2, by heart it. Definitely question you can see from this part, basicity in aqueous phase. Okay, secondary, primary and tertiary. The 3 reasons. First one is inductive effect. Second one is solvation effect, and third one is steric hindrance. Okay, in the case of methyl substitution, the solvation effect will be dominating, and which will decreases the basicity and all. In the case of ethyl, the steric hindrance will be dominating, and that will be increasing the decreasing the basicity of primary amine. That is why there is 1 3 here and there is 3 1 here. Shall I move, students? Are you done? Just note down these points, that is only enough. Yes. Okay, these are 3 factors. Plus effect favors tertiary always, then solvation effect, and solvation effect always favors primary, and steric hindrance will be favoring primary. In the case of ethyl, okay, in the case of either substitution, you can see solvation effect is greater, so the primary is having greater. In the case of either substitution, you can see the inductive effect will be dominating, and that will be increasing the basicity of it. Yes, next one is basicity comparison of aliphatic amine, aromatic amine, and amine. Among the order, aliphatic amine is greater than aliphatic amine. The basicity of aliphatic amine is always greater than aromatic amines. Aliphatic amine is always greater than aromatic amine. Okay, what is the reason? NH2, we can see NH2, the lone pair in nitrogen, is involving in the delocalization, is always involved in the delocalization. Because of that, this lone pair of nitrogen is not easily available for donation. So the basicity will be lesser for aromatic amine. Okay, that is why aliphatic is greater than NH3, then aromatic amine will be coming. Okay, that is the general order for the basicity. Shall I move to the next, students? Yes. Okay, next one is effect of substituents on aniline. And aniline, we all know that aniline is a strong activating NH. In that NH3 is a NH2 is a strong activating group, and as it is an activating group, what is going to happen? What is going to happen? The basicity and acidity will be changing. That is, if NH3 NH2, if I am just introducing NO2 group in this NO2 group, if I am introducing an NO2 group in aniline, what is happening? This is an electron withdrawing group. What it will be doing? It will be decreasing the basicity. Instead of that, if I am attaching an electron donating group, what is going to happen? It will be increasing the basicity. And that already all of you know. That is, plus I effect will be increasing the basicity and minus I effect will increases the acidity. Now the point you note down is ortho effect. We have discussed about ortho effect in the carboxylic acid. A similar effect you can see in the case of aniline also. That is, ortho substituted aniline are always less basic. If I am just taking aniline here and I am just taking which one? I am just taking NO2 here. First one or second one, which is more basic? First one or second one? Students, tell me. Which is more basic, aniline or orthonitroaniline? Which is more basic, students, tell me. Yes, first one is more basic. Why first one is more basic? And what if I am asking one more NH2, and if I am introducing CH3 group, is which one is more basic? Here also aniline is the more basic. Here this is an electron withdrawing group and this is an electron donating group. That is, in the case of aniline, if I am attaching electron donating group or electron withdrawing group in the ortho position, there will be steric inhibition of resonance. Due to the steric inhibition of resonance, there won't be any proper delocalization of electrons. There won't be any proper delocalization. As there is no proper delocalization, the lone pair in nitrogen won't be enough electron rich. Because of that, it won't be available much for donation. So its basicity will decreases. But here you can see there is a smooth flow of electron. Whenever this lone pair want to donate this electron. Okay. So because of that, nitrogen will be sufficient electron rich, and they can easily donate. That is the reason. Yes. Hope all of you understood the ortho effect. Now we can move into the next. Just note down ortho effect. Aniline is more basic than ortho substituted aniline. Okay. Next we will be moving into the chemical reaction and distinction test. For amine. First one, this is a definitive test for primary amines only. It's a very important test, that is carbalamine test or isocyanate test. All of you might be knowing this reaction, isocyanate test. What is isocyanate test? Primary amine will be converted to isocyanate. How we can do this one? Just convert NH to Rn to Rc, Rn to Rnc. That is only you have to do. RNH2 to Rnc. For that, what you can do is just remove the 3 chlorine from the chloroform and 3 potassium from the KOH, and resulting we will be getting 3 KCl. Resulting we will be getting 3 KCl, and the remaining water, remaining hydrogen and oxygen. Remaining hydrogen and oxygen, if you observe, that will be forming 3 molecules of water. Then what is remaining? This nitrogen and this carbon. This nitrogen and this carbon will be forming isocyanate. That is how easily you can remember the reaction. Okay. And note down how we can understand whether we got our product or whether the amine that we have used is primary amine. If there is a formation of foul smelling substance, then we can confirm that the amine that we have taken is primary amine. And note down secondary amine and tertiary amine did not give this test. It work for both aliphatic and aromatic primary amine. So carbolamine test will be given by both aliphatic as well as aromatic primary amine. That's the point you have note down. All primary amine it will work, whether it is aromatic or aliphatic, and it won't work for secondary and tertiary amine. Yeah, have you noted down all the points? It's a very important one. Carbolamine test, also called as isocyanate test. Remember the reagent and remember how the product easily, how you can write the product easily. Shall we move, students? Yes. Okay. Next one is Hinsenberg test. It is also a test which is used to separate primary, secondary and tertiary amine using benzene sulfonyl chloride. That is yes, double bond O Cl. This is benzene sulfonyl chloride. And when this benzene sulfonyl chloride on reacting with the primary amine, what I will be getting will be forming a sulfonamide, or I can write it primary amine on treating with C6H5SO2Cl. What I will be getting? I will be getting N alkyl sulfonamide. And this one on treating with the NaOH or an alkali, what I will be getting? The salt will be soluble. Yeah, the salt which is forming it is sodium salt of benzene sulfonamide. Sodium salt of benzene sulfonamide, and this sodium salt of benzene sulfonamide is soluble and is water soluble, so that we can confirm that it is primary amine. Now if I am taking secondary amine, again it will be forming sulfonamide, again it will be forming NN dialkyl sulfonamide, because it is secondary amine, and that secondary amine which formed NN dialkyl sulfonamide on treating with NaOH we will be getting a insoluble product, and the product that won't be soluble in alkali. That is how we can understand secondary amine. Now tertiary amine, it's not at all going to react with the Hinsenberg reagent. Tertiary amine, it's not at all going to react with Hinsenberg reagent. Okay, this is the point you have to note it down. Okay, shall I move, students? Hinsenberg test, primary, secondary and tertiary. Primary is for N-alkyl sulfonamide, then which on treating with NaOH we will be getting sodium salt of benzene sulfonamide, which is soluble in water. Remaining are insoluble and no reaction. Yes. Now the next one is reaction with the nitrous acid. Reaction with the nitrous acid also will be helping you to understand whether it is primary, secondary or tertiary amine. Yes, how we can understand this one? Nitrous acid, it is formed by the treating NaNO2 plus HCl. If I am treating primary aliphatic amine or NH2, primary aliphatic amine on treating with NaNO2 plus HCl, what I will be getting? RN2Cl. We will be getting a alkyl diazonium salt, and this is very unstable. And it will be converted to ROH, alcohol. Primary aliphatic amine on treating with nitrous acid we will be getting alcohol. Now, okay, now in the case of primary aromatic, what I will be getting? Primary aromatic, that is NH2, aniline. If I am taking aniline which on treating with NaNO2 NO2 HCl in 0 to 5 degrees Celsius. In 0 to 5 degrees Celsius, what I will be getting? I will be getting N2Cl, and this salt is stable. This is benzene disodium chloride. Benzene disodium chloride. This is stable. This is stable under 0 to 5 degree Celsius temperature. Okay. Now what about the secondary amine? Secondary amine, what I will be getting as a product? I will be getting yellow oily nitrosamine. Yellow oily nitrosamine. That is, if I am taking RNH, R, okay, Na, NO2 and HCl. If I am treating, what I will be getting? RN, no. Okay, this is the product, that is, this is nitrosamine, the product you are getting. Okay. Now if I am taking a tertiary amine, RN, what is the product we are getting? What is the product we are getting? Na, NO2 in presence of HCl, RN, R, NO2 minus. I will be getting a quaternary salt, that is disodium salt I will be getting if I am using, that is soluble in quaternary salt. This is the product that I will be getting on reaction with a different one. Okay. So note on all these things. Primary aliphatic amine will be giving alcohol, and primary aromatic amine will be giving a stable benzene disodium chloride, and secondary amine will be forming yellow nitrosamine, and tertiary amine will be forming a soluble quaternary salt, nitrite salt. This is what the point you have noted down in the case of reaction with the nitrous oxide. This is how we can differentiate primary, secondary and tertiary. Yes. Are you clear, students? Done everyone? Yes. Shall we move? Okay. Okay, you can write down note on the name. Tertiary ammonium nitrite salt. Tertiary ammonium nitrate salt. Just take a screenshot of it. Question can ask from anything, any part of this. Okay. Moving. Okay. Next is about diazonium salt. This is another important part of this chapter, that is diazonium salt. How the diazonium salt is preparing? Diazonium salt is preparing when aniline is treated with NO2 and HCl in 0 to 5 degrees Celsius. What I will be getting? I will be getting benzene disodium chloride, N2Cl, benzene disodium chloride. Now it's very important to know what are the different reactions this benzene disodium chloride will be undergoing. That's another important one. Yes. Okay, we'll be moving into that one. That is the reaction that is involved by benzene disodium chloride. That is, first one is displacement of nitrogen. First one, that is Sandmeis reaction. Sandmeis reaction, it will be using CuCl or HCl. That is, if I am taking benzene disodium chloride, N2Cl. If I am using CuCl bar HCl, or if I am using CuBr or HBr, what I will be getting? I will be getting chlorobenzene. And instead of that, if I am using copper powder in presence of HCl, what I will be getting? I will be again getting Cl. And these two are different reactions. The first one name is Sandmeis reaction. Second one is Getterman reaction. Okay. Now one more reaction is there, that is not one more, few more are there. This one is Ball-Schiemann reaction. Ball-Schiemann, if I am treating HBF4, to the benzene disodium chloride, what I will be getting? I will be getting N2 BF4 minus into BF4 minus, and this one again heating we will be getting fluorobenzene. We will be getting fluorobenzene, because in the case of Sandmeyer and Gutterman, we can only prepare cyanide, chloride and bromobenzene. We can prepare only these three benzene groups, and if I want to prepare fluorobenzene or iodobenzene, I have to follow some different reaction. If I want to prepare chlorobenzene, how I have to do? I have to treat benzene disodium chloride with potassium iodide. On treating with the potassium iodide, I will be getting iodobenzene. Now if you want to prepare phenol, what you have to do? You have to add water. You have to add warm water. And on adding warm water, what I will be getting? I will be getting phenol here. Okay. So, and also one more reaction is there. If I am treating H3PO2, I will be getting benzene. So these are the important reactions you can note down for disodium chloride. Any of these things can ask in the question exam. Note down all of you. Okay. Benzene, then phenol, iodobenzene, fluorobenzene, chlorobenzene, or cyanobenzene or iodobenzene, anything we can prepare by using benzene disodium chloride. Okay, just take a screenshot or note down all these points in your notebooks. If you are done, we can move into the next. Are you all done? Yes. Yes, thank you students for your response. Next one is retention of nitrogen. That is coupling reaction. How we can produce dye using the coupling reaction of disodium salt. Okay, how we can prepare? First one is orange dye. How I can prepare orange dye? It's very easy only. Orange dye we will be preparing it from phenol. This phenol on treating with benzene disodium chloride. What we can do, just remove the hydrogen and chlorine, then bind it together by using N double bond N. This is what the coupling reaction. These two are coupled together and we will be getting the final product. This is called as para hydroxy azobenzene. That is N2 group is there, so azobenzene. Okay, and this is what we call it as orange dye, para hydroxy azobenzene. Okay, now the next one with the aniline we can produce yellow dye. Using aniline we can use yellow dye. The same method only, there is no much difference. Here also same thing, we will be removing HCl and just coupling it together. Just remove HCl and we will be coupling it together by using N double bond. Okay, and what I got, I will be getting aniline yellow. So this is what we call it as yellow dye, and the name is para-aminobenzene. Para-aminobenzene. Okay, this is how we can form or we can produce dyes. These are two important dyes you have to learn. Yeah, have you understood how we can form the dye, the reaction, the mechanism and everything? Just eliminate HCl and then couple the two ring together. You will be getting the product. That's only the thing. Okay, students, have you noted down? Shall we move? Yes. Next one is another important, that is electrophilic substitution of aniline. Electrophilic substitution of aniline, phenol have lot of difference is there comparing to the other substitution, electrophilic substitution reactions. Okay, first of all we know that bromination, nitration, sulfonation, these are the three important, bromination or halogenation, sulfonation and nitration, these are three important reactions that we will be discussing. Okay, important aromatic substitution reactions. Okay, now what is the difference or what is the important point in this one, that I will be discussing it first one by one. If I am taking, sorry, okay, suppose if I am taking about the bromination reaction. Bromination, we know that aniline is a strong activating group, NH2 group. As aniline is a strong activating group, Br2, what is the product I will be getting? I am taking a non-polar solvent. What is the product I will be getting? I will be getting I will be getting 2,4,6 tribromoaniline. I will be getting 2,4,6 tribromoaniline. And if I am taking a polar solvent Br2 in presence of water, there also I will be getting what? There also I will be getting tribromoaniline. All these three I will be getting tribromoaniline. But how I can prepare? I won't be getting monobromoaniline by using the direct halogenation reaction. Then how I can prepare? Monohalogenation or monobromoaniline by using a acetylation of aniline, by using acetylation, monobromination. Because why there is a 3 bromine group attached is because the ring is very much activated. What you have to do is you have to attach a substituent or a group which can deactivate this ring. Using that we can form monobromoaniline. Yeah, monobromination. Acetylation of aniline. NH2 CH3 C double bond O Cl. Okay, what will be, there will be a formation of carbocation here, and that carbocation will be attaching on the ring, and okay, this carbocation will be attaching on the para position. Okay, no, just a minute. Okay, in the acetylation process, there will be lone pair here, and the lone pair will be attaching on this carbocation and resulting in the formation of NHC double bond O CH3. NHC double bond O CH3. Now you can see there is an electron withdrawing group. This is an electron withdrawing group. This aniline now it is not that much activated. Now in this deactivated part, what I have to do is I have to do the bromination in presence of CS2. If I am doing bromination in presence of CS2, I will be getting bromine attached on the para position Br. CH3, bromine attached on the para position. And then now what is the next step? Next step is we have to remove this acetylated product. For that I will be adding water, and what I will be getting HOH. HOH will be attaching, and I will be getting the aniline back, NH2, and then bromine plus CH3 C double bond O OH. I will be getting monobromoaniline plus an acid. Okay, this is how we can make monobromination. Direct monobromination is not possible because NH2 is a highly activating group. We can find out the monobromination product by deactivating the ring by doing acetylation. Got it, everyone? Just go through it. Just tell me, is it clear or not? Yes. Okay. Now a few more points is there, that is about the nitration reaction. In the case of nitration, also there is some problem. Nitration, we are expecting we are expecting ortho and para because it is an activating one. Concentrated HNO3 and H2SO4, concentrated HNO3 and H2SO4. What I will be getting? NH2. I will be getting, of course, I will be getting ortho, para, and nitro, ortho, para, and meta, nitro, aniline. Okay, NH2. Now the question is among this which is the major one? Which is the major one? Here, anyhow the para is a major one. Para is a major one. It is forming 51%. Para is a major one. It is a 51%. Now after para, which is the next major one? That is the question. What is the question? What is the next major one? We will be expecting that ortho is the next major one, but actually ortho is not the next major one. Meta is the next major one. Meta is coming around 48% of it. Meta is coming around 48% of it. Why meta is more stable comparing to the ortho? Anybody have any idea? Why meta is more stable comparing to? Anybody have any idea? Guys, tell me. Anybody have any idea why here meta is more stable or major product comparing to ortho? What is the reason? The reason is the reaction is taking place in acidic condition. As the reaction is taking place in acidic condition, the lone pair of nitrogen will be attacking on the proton. Lone pair of nitrogen will be attacking on the proton, which results in the formation of a anilinium ion. And we know that this anilinium ion, it is a electron withdrawing group. It will be deactivating the ring. This will be deactivating the ring. So because of that, we will be getting a meta product. Deactivating group will be giving meta as the major one, right? And the deactivator is not that strong enough. So I will be getting meta with the 48%. Okay, this is the reason why in the case of nitration, meta is coming as a second major product. The percentage is important. Note it down, everyone. Yes, are you done, everyone? Shall we move to the next one, sulfonation reaction? Yes. Now the last one is sulfonation reaction. Note it down. Sulfonation. Everyone know the sulfonation, that is NH2 in presence of H2SO4 in presence of H2SO4. What is the product we are getting? Yeah, we will be getting the para one. Para is a major one, and this para product is actually existing in a sitter ion form. It will be existing in NH2, NH3 plus. It will be existing in sitter ion form. You know, the reason you all know, right? This is taking place in presence of H2SO4. As it is taking place in H2SO4, there will be a chance that this lone pair will be taking the proton, and because of that, you can see it will be existing in NH3 ion form. Okay, that is what we call as sitter ion. Got it, everyone? Yeah, in the case of bromination, nitration, and sulfonation, 3 different cases we have seen. Okay, it is not going in a direct way. In the case of bromination, if you observe, we will be getting tribromo, aniline only in both the case, in presence of both polar and non-polar solvent. And how we can get monobrominated product? By the acetylation reaction. Through acetylation, we will be deactivating the ring, and then we will be introducing the halogen, and thereby we will be getting a monohalogenated product. Okay, next one is nitration. In the case of nitration, we are expecting that ortho and para is a major one, but according to the experimental thing, it has been found that para is a major, then it is coming meta is around 48%. And in the case of sulfonation, the para product will be existing in sweeter ion because the condition is acidic condition. So acidic condition, lone pair nitrogen will be catching proton and will be existing in this sitter ion form. Sitter ion. Okay, So this is the complete reactions and important points regarding the aniline. Now we can do the questions from this chapter, and we can make more clarity about this chapter. Okay, so guys, are you ready for doing the questions? Shall we start? We will be discussing few questions. After that I will be winding up the class. You can go and take the rest. Okay. Yes, thank you. First one, the correct order of decreasing basic strength of given amines. Decreasing basic strength of given amine. What is the correct order? Basic strength also, basic strength is always depend upon the plus effect. More the plus effect, more will be the basic strength. So among these, check which is having more plus effect. You see N-ethyl ethanamine. N-ethyl ethanamine. What is this N-ethyl ethanamine? Yeah, this is what N-ethyl ethanamine. N-ethyl ethanamine. And in the case of N-ethyl ethanamine, you can see there are two inductive effects here. 2 plus a group is there. And now in the case of ethanamine, either CH3, CH2, NH2, ethane, ethanamine, ethane, amine. Then N-methyl aniline. N-methyl aniline, if you observe, what is N-methyl amine? This is what N-methyl aniline. Then benzene amine, that is aniline. Okay. Now among these, which is more basic? Already we have discussed that aliphatic amines are more basic comparing to aromatic amine. So among these first one and second one, these two, first one and second one will be more basic comparing to the third one and fourth one, if you observe. Now among the first one and second one, which is more basic? Yeah, Kiran saying meta formation of unlinear ion. Yes. Yeah, in the case of meta. Okay, Kiran, what you asked 5 minutes before? Meta formation of unlinear ion. Yeah, it's due to the formation of unlinear ion. It is comparatively more stable. Okay. Secondary. Okay, what is secondary you mentioned? Okay, so among these we can see there are two inductive group is there, so it is going to be more basic. Then comparing to that one, this one is more basic. Now comparing to these aromatic group, these two aromatic group, which one is more basic? Here there is a inductive effect is there. Due to inductive effect, this lone pair of nitrogen will be more easily available, or it will be in electron rich. So this is more basic comparing to the benzene. So what is the order? First one is the order. N-ethyl amine greater than ethanamine, then N-methyl aniline, then benzene amine. That is the order. Have you all got the same answer? Yes. Okay, now the next question is, yeah, go through it all of you. A nitro compound is there and also C2H5 group is there. It will be treating with Cl2 in presence of FeCl2, then SnHCl, then NaNO2 bar HCl, then treating with the potassium iodide. What is the final product? Go through it and give me the answer in the chat box. Yes, anybody got the answer? Anybody got the answer? A, B, C, D? Okay, I will be solving it. C2H5 NO2. What is this one? Cl2 in presence of FeCl2. Halogenation reaction. It is just a halogenation reaction. And here already para is substituted, so I will be placing chlorine in the ortho position. C2H5, and this is the chlorine here, and NO2. Okay, now next I will be treating it with the SnHCl, SN bar HCl. SN bar HCl, just now we have discussed what SN bar HCl will be doing to a nitro compound. What SN bar HCl will be doing? Anybody here can give the answer? Nitro group, yes. Yeah, it is a reduction, not the hydrogenation. Hydrogenation is using the Raney nickel or platinum palladium catalyst. Here it is happening the reduction by using tin or HCl. Reduction to aniline C2H5Cl and NH2. Now next one, this will be treating with the NaNO2 bar HCl, diazotization NaNO2 bar HCl in presence of 0 to 5 degrees Celsius, diazotization. And what I got here, H5Cl N2Cl. Now after this diazonium chloride will be treating with the potassium iodide. This also we have discussed. What is the product we will be getting here? If I am treating diazonium chloride with potassium iodide, what is the product? This also we discussed in the class. Tell me guys, what is the product we are going to get? Yeah, this N2Cl will be replaced by iodine, C2H5Cl, and I will be getting an iodine here. Okay, this is the complete reaction. And what is the answer here? Yeah, what is the answer? Yeah, option 3 is the answer. Note down the complete reaction. You have to remember what are the reagents which will be doing in this particular reaction. Okay, shall I move to the next question? Are you all done with this? Yes, we'll be moving to the next question. Compound that does not undergo Friedel-Crafts alkylation reaction but gives a positive carbolamine test. Yeah, what is the answer for this one? Which compound will be giving carbolamine test but it won't be giving Friedel-Crafts alkylation reaction? Yes. Yeah, what is the answer? What is the answer? Anybody got the answer? Which group? We all know that carbolamine test is given by which group? Primary amine, secondary amine or tertiary amine? Which amine will be giving carbolamine test? Yes, very good Kiran, option A is the correct one. And carbolamine test will be given by primary amine. We know that aniline is a primary amine. So aniline will be giving carbolamine test. And also here it is mentioned that the compound that does not undergo Friedel-Crafts alkylation. Aniline won't undergo Friedel-Crafts alkylation. Why? Why aniline won't be undergoing? Won't undergo Friedel-Crafts alkylation. Won't be undergoing Friedel-Crafts alkylation. What is the reason? What is the reason? Because we know that this NH2 aniline, which will be aniline on, if I am treating aniline with anhydrous AlCl3 Rx in presence of AlCl3, what is going to happen is this lone pair in aniline, lone pair will be in aniline will be donating electron to the aluminium and will be forming NH2 AlCl3. It will be forming NH2 AlCl3 complex, and this is a deactivating group, and due to the deactivation it won't be giving Friedel-Crafts alkylation reaction. Okay, that is why aniline. And pyridine, we know that it is a secondary. And N-methyl aniline it is also a secondary, and triethyl amine it is tertiary. So secondary tertiary is not going to give carbolamine test, so that is not going to be the answer. Is it done everyone? Shall we move to the next question? Are you all done? Shall we move to the next question? Note on the point, aniline won't be undergoing Friedel-Crafts alkylation reaction due to this reason. Yes. Moving. Okay, another question. This is for you. All of you solve it and get me the answer. Cu2Br2. What is this reagent? Just now we have discussed. Then magnesium in presence of triether. Yeah, what are these? Tell me answer. Tell me guys, what is the answer for this one? What is this one? Cu2Br2 in presence of HBr. What is that reaction called? What is that reaction called? What is that reaction? I hope all of you know it. What is the reaction? Sandmace, very good. It is Sandmace reaction, and due to Sandmace reagent, the product that we are getting is bromobenzene here. Bromobenzene, and this bromobenzene on treating with the Mg magnesium in presence of dry ether. Magnesium in presence of dry ether. This is the method of preparation of Grignard reagent. As a result, we will be getting the Grignard reagent. MgBr. Now this Grignard reagent on treating with water, H2O, what we will be getting? We will be getting benzene here, HOH. I will be getting benzene plus MgOH Br. This is the product we are getting here. Okay. Got it, everyone? Have you all got the final answer? Yeah, the final answer is benzene. Are you all clear with this question? Shall we move to the next? Or any doubt anybody is having? Okay, we'll moving on to the next question. Okay, give me the answer for this one. Which of the following reactions will not give primary amine as a product? We don't want primary amine, we want secondary or tertiary amine. That's the question. Look onto the question carefully and get me the answer. Yeah, anybody got the answer? It's a very easy question. Already we have discussed this one. What is the answer? Cyanide already we have discussed. CH3, CH2, CN. We are getting primary amine. And what about isocyanate? In the case of isocyanate, we already discussed that CH3, NH, CH2. We are getting secondary amine in the case of NH3. Secondary amine in case of isocyanate. That is what we already discussed. Most of the case there is preparation of primary amine, and one of the preparation of secondary amine is by using isocyanate. Then here you can see this is amide. And amide we all know that it will be converting the carbonyl group to CH2, and we will be getting amine, primary amine. And here also same thing, Br2 in presence of KOH, Hofmann bromide degradation. We will be getting amine with one carbon less, CH3 NH2. All are primary amine. This is only secondary amine. So this is our answer. Is it done, everyone? Shall we move? Yes. Yeah, another question. All of you do it. CH3CO twice O, that is anhydride in presence of pyridine. Then it will be treating with lithium aluminum hydrate, and then on adding water we will be getting a product. Yes. Get me the answer. Anhydride. From the anhydride, how we can get the product? Yeah, this is the anhydride, right? CH3, C double bond O, O, C double bond O, CH3. This is the anhydride. And how this anhydride will be splitting? This will be splitting to generate the electrophile, and this electrophile will be attacking on the lone pair of electron, or the lone pair will be attacking on the electrophile, resulting in the formation of NH C double bond O, NH C double bond O, CH3, NH C double bond O, CH3, and this one on adding water, H2O. Not adding water. This one on treating with lithium aluminum hydride. Lithium aluminum hydride, we all know that this is an amide, right? This is an amide. Lithium aluminum hydride, it will be reducing it to amine. So amide will be reducing to amine, NH CH2 CH3. This is the product we are getting. Now this one on treating with H2O, on treating with water, what we will be getting? This amine on treating with water, what I will be getting as a product? What I will be getting as a product? Yeah, okay. And this lithium aluminum hydride is actually reducing it in presence of water only, reducing it in presence of water, and you will be getting the final product. Yeah, where you can see this product in the answer? Yes, option B is the answer. Sorry, okay, as you maybe you have mistaken by as A, B, C. This is option A, this is option B, and this is option C. Option C, B is the answer. Okay, yes, good. Thank you, Yogesh and Kiran. Shall we move to the next question, guys? Yes. Okay. Yeah, here is the next question, NEET 2022. Which of the following sequence of reactions is suitable to synthesize chlorobenzene? Very easy question. How we can prepare chlorobenzene? Option A, B, C. Find out the answer. Very easy question. By looking itself, we can understand. Anybody got the answer? Anybody here can give me the answer? Option A, B, C. What is the answer? By looking itself, we can see, right? Benzene in presence of benzene, halogenation, that is chlorination here, anhydrous FeCl3. What I will be getting? I will be getting the chlorinated product, that is chlorobenzene. And here it is phenol. Phenol on reacting with NaNO2 and HCl. Yeah, it's not going to happen. Aniline on reacting with NaNO2, we will be getting disonium chloride. That on treating with the CuCl, we can get chlorobenzene. And here benzene can't do substitution by using only HCl. And here also aniline HCl is not going to give chlorobenzene. So only the answer is A. Okay. Done? Are you all done? Yes. We'll move to the next question. Yeah, here is another question, NEET 2019. The correct order of basic strength of methyl substituted aniline in aqueous solution. Here it is clearly mentioned it is methyl substituted. If it is methyl substituted, what is the order of basic strength? What is the order of basic strength? Option A, B, C, D. Give me the answer. Give me the answer in the chat box, students. Option Option C. Very good, Yogesh. Already I have discussed for methyl what is the order? Secondary greater than, primary greater than, tertiary. So just check which is secondary in the options. So here you can see in the case of option C, yeah, secondary methyl, then primary, then tertiary. So that is the order of basicity. Order of basicity. Yes. Got it, everyone? Shall we move? Yes. Yeah, few more questions. Which of the following sequence of reaction is suitable to synthesis chlorobenzene? Okay, already we discussed this question. Okay. Okay, another question. Primary aliphatic amine react with HNO2 to give unstable diazonium salt. You have to check whether it is correct or wrong. Primary aliphatic amine react with HNO2 to give unstable diazonium salt. Is it correct or wrong? Tell me. Give me the answer in the chat box. Are you saying it is correct? Or it is wrong? It is correct. Yes, it is primary aliphatic amine. Already we have discussed. It won't be giving a stable one. It will be converting to alcohol because it is very unstable. So this is correct statement. Now what about second one? Primary aromatic amine react with HNO2 to form diazonium salt which are stable above 300 Kelvin. Is it correct? Primary aromatic amine or aniline which react with HNO2 gives diazonium salt, and it is saying that it is stable above 300 Kelvin. Is it correct? Tell me, students, is it correct or wrong? Is it correct? Yes, it is wrong. Why? Because it is stable only at, we discussed, it is stable only in 0 to 5 degree temperature. Only in low temperature only it is stable. Okay. Now the answer is statement 1 is correct and 2 is incorrect. Moving to the next question. Yeah, another question for you. Do it. nitrile group on treating with lithium aluminum hydride, then NaNO2 plus HCl, and then on treating water, what is the product you are getting? Find out the product, everyone. What is the answer? Anybody got the answer? Option D. Yes, very good. Option D is the correct one. Okay, how we can solve this? Cn on treating with lithium aluminum hydrate and water. What I will be getting as a product? CH2 NH2, CH2 NH2 reduction, and then which on treating with the NaNO2, NaNO2 plus HCl, NaNO2 plus HCl, what it will be converting? CH2 into Cl, and this one on treating with the water, H2O. This is very unstable, and we know that it will be converted to alcohol, that is benzyl alcohol we will be getting as a final product. Note it down, all of you. Yeah, shall we move for few more questions? It's a small chapter, you maximum focus on the questions from this chapter and get a complete clarity. Yes. Okay, so one more question. Identify the compound that will react with the Hindenburg reagent to give a solid which dissolves in alkali. What is the answer? What is the answer? We already discussed this one in the class. Hindenburg reagent will be forming a compound that will be dissolved in alkali. Which is that compound? Option C. Yes, very good. Option C is the correct one. Why? Because already we discussed Hindenburg reagent will be primary amine. Primary amine will be giving what? Soluble. Primary amine will be giving a soluble compound, that is benzene sulfonamide, N-alkyl benzene sulfonamide will be reacting with a NaOH and we will be getting a soluble product. And secondary amine we won't be getting a soluble product. We will be getting a product but that is not soluble. And tertiary amine won't even react with the Hindenburg reagent also. So option C, which is the primary amine, is the correct answer. Okay. Yeah, here is another question. Already we discussed also this in the class. Go through it and give me the answer. Nitration of aniline in strong acidic medium also gives meta-nitroaniline. What is the reason? What is the reason? Just now we discussed about this. A, B, C, D. In spite of substituents, nitro group always goes to only meta position. Is it correct? No. In electrophilic substitution reaction, amino group is meta-directive. No way. In the absence of substituents, nitro group always goes to meta position. Is it? No. In acidic medium, aniline is present in anilinium ion. We already have discussed this one. In presence of sulfonation as well as in presence of, or in the case of nitration, we can see acid is there. Because of the presence of acid, there will be hydration. Not hydration, there will be attachment of hydrogen on the nitrogen, which is forming anilinium ion. That is the reason why it is giving meta nitroaniline in a good amount, that is 48%. Yes, hope all of you got it. We'll be moving to the next question. Okay, yeah, that's all about the today's class. Questions already we have done maximum number of questions from this chapter. Hope all of you got a clear cut idea about this chapter. Just go through the important reaction that I have taken, that is the high priority one, and also try to do maximum questions from this chapter. Yeah, hope all of you understood all the things about this amine chapter. Yeah, we can wind up this class as we have covered most of the things in this chapter. Yes, do you guys have any question or any query or anything? If you have anything, we can talk and we can, or else we can wind up the section. Guys, are you fine with it? Yes. So all of you try to solve maximum questions. Now we don't have much time. We will be only maximum 10 days only remaining in the NEET exam. To try to do maximum revision. Whatever topic you have taken, do a proper revision and also do maximum number of questions as much as you can. Okay, and get a complete clarity of all the chapters. Okay, so NEET exam, you know that you have to score around 600 or 550 plus to get at least good medical college and all. So the practice section is very important for that one. More syllabus you have to cover, and thereby you have to get more score. Okay, so that's all about today's class. Okay, all of you can go for lunch. We'll see you in the next class with another chapter, that is haloalkanes and haloarenes. Yes, thank you all of you. Thanks for joining.